Hey there, chemists. I want to do our week 10 summary video where we got our first introductions into acids and bases, and I kind of like this meme, a little bit political, but it made me laugh. Once again, I'm asking for your protons, haha. According to the Bronston-Lowry theory, gotta laugh. Okay, so highlights from the week. It was our Thanksgiving week, and I hope you guys had a wonderful holiday and had at least some opportunity for rest and restoration and maybe some time with family. As I said in our announcement, I had actually a really, really nice one, which was good because I was a little bit disappointed going into it that I might not be able to have as good of one as normal. I know there's some historical tradition with Thanksgiving about what it's celebrating in terms of the birth of our nation, but I just really love the idea that we have a holiday that is about giving thanks, regardless of any history. I just think that's a really great, good for your mental health strategy. So I was really grateful. I have a lot to be grateful for, and I hope you realize you do too. So let's talk then about the learning objectives from the week. It was a lot less because, of course, it was a very short week in terms of content. So a lot about like those theories of acids and bases and hydronium versus hydroxide, and then conjugate acid-base pairs, which is probably the trippiest part for students. So kind of pay attention there. So I know the discussion was optional, and so some of you totally understandably would choose not to participate. Those of you who did will receive some extra credit points. But I do think it's valuable to go over those discussion answers anyway, because this is still the content and they can help maybe prepare us for test questions. And since we will be having our Unit 4 test at the end of the week, I still think there's value in reviewing the answers or potential good answers to those questions. So starting off with, what is the conjugate base of carbonic acid, and what does that even mean? So here we have the structural formula for carbonic acid, and here we have its molecular or chemical formula. So you can see there's a big difference in what it looks like here and what it actually looks like. And so the conjugate base is the bicarbonate ion, also known as hydrogen bicarbonate, but it is down a proton, so a hydrogen less, and up a negative charge, just like the student included right here. And I really loved this particular student, who I believe was in the section 1 discussion group. I just left you in sections rather than break you into individual groups. I really love the way they walked through how they figured that out. So the conjugate acid-base pair, as I showed you in that modeling video, it's like what's on the back of the card. If this chemical reacts with water as an acid, it's going to be donating the proton to water. So just like the student is saying right here, this is the reaction she got. If it reacts as an acid, carbonic acid, it creates this. And in reverse, and it's that reversibility that makes this then a potential base. It could be a hydrogen acceptor. So that's where we get the idea of this being an acid and this being its conjugate base. Once it behaves as an acid, once it donates a proton, what does it become? That chemical species that it becomes is its conjugate base and could potentially re-accept a proton, acting then not as an acid but as a base. So great explanation there. Maybe if you want to pause the video and take a chance to really read through that, it was really good. This meme, I've seen this meme used in a lot of different ways. I kind of like this one because it just kind of makes me laugh. It's a really simple, like, water's so stressed out on which is it going to be. I don't remember if it was in the Ed Puzzles from this week, but you may have learned that the most common acid in the universe is water, and the most common base in the universe is water. And so a section 1 group student pointed out that water can act as both an acid and a base. When it acts as an acid, it donates a proton, and then it becomes then the hydroxide ion. When it acts as a base and accepts a proton, it becomes that hydronium ion. And so it's that amphiprotic. If you look at this word really closely, amphiprotic, it has a root in it, amph, A-M-P-H, which if you think of other words that have it in there, like amphibian, it means both. So amphibians are, those cute little creatures like salamanders and frogs that spend some of their life on land and some of their life in the water. So they're both aquatic and land animals. So that's where that word comes from. So that's where amphiprotic comes from. And it's many, or both. It can act as both a base or an acid, both a proton acceptor or a proton donator. Do you think the following injury is from a strong acid or a weak acid, and explain? So I have 2 different responses I want to get into. The first one is, as we learned from the videos, no, this is actually an example of an injury, and actually a fairly small injury from hydrofluoric acid, which is weak but very, very dangerous. If you Google hydrofluoric acid injuries, you better be prepared for some pretty nasty pictures because they can be really bad. And that has to do with just the nature of hydrofluoric acid. It actually penetrates into your tissue and it does some of the damage on the inside. And so a lot of times a person who's gotten the spill on them doesn't even know it until they start to notice the tingling and the nerve damage portion. So how dangerous an acid is doesn't necessarily depend on the strength and the weakness. How dangerous it is depends on what acid is and how concentrated it is. So like sulfuric acid, it really concentrated is really dangerous, that's true, and it is a strong acid, but hydrofluoric acid is also really dangerous and it is a weak acid. So our brain wants the word strong and weak to have to do with the amount of danger, but that's just not what they mean. As another student in a different section pointed out, acid-base strength is about equilibrium constants. It's about the reversibility of their reaction. Strong acids are not particularly reversible. At equilibrium, products are completely favored, or so favored that there's hardly any reactants left. Whereas weak acids, the reactants are actually usually mostly favored. And so hydrofluoric acid, even though it is incredibly dangerous, has a highly reversible reaction. So you have the hydrogen and the fluoride separating, but mostly they stay in that neutral molecular form. Excellent job on that question. What do you think is being conveyed with the following image as it pertains to bases? So a student in section 2 answered this really well, and I really liked even the wording of this. This picture is showing that bases follow the Bronston-Lowry theory as being a proton acceptor, but a smaller number can be considered both Arrhenius and Bronston-Lowry. And then goes on to kind of explain that in terms of those two theories. And then this sentence here at the bottom, all bases are Bronston-Lowry bases, but not all bases are Arrhenius. So if you fit into this category, the Arrhenius, you automatically also fit into Bronston-Lowry, but not necessarily the other way around. And the most common example for that is ammonia, NH3. NH3 is a Bronston-Lowry base in that it can accept a proton to make ammonium, NH4, with a positive charge, but it doesn't meet the Arrhenius definition because the Arrhenius definition is all about that direct contribution. And I thought the student made another good point is this, like everything else in science, they thought they had it figured out, and then they learned more things and they had to add and modify to that theory. And we're getting to see how messy science is in real time with like the COVID-19 response. On like, as we're learning as we go, sometimes we have to backtrack and re-explain things like, oh no, it masks should be worn, when originally it was like, no, it probably spreads like the flu, and then it turned out it didn't. So science is a messy process in the moment, and as you learn more, you have to make modifications and expansions to your theories. So last questions, what acid and base are you familiar with or have you interacted with? How does it relate to your life? This is a question you should always be asking yourself with any of the content. And the reason for that is the way our brains work to learn material, the more places you can connect it to pre-existing knowledge, the more strongly it will be retained. So it's kind of an interesting phenomenon then. The more you learn, the better you can learn because you'll have more experiences and things to connect it to. So you should always be asking yourself, how does this content relate to my personal life? So I just wanted to share with you a couple ways people address this. So this student lists 3 different acids that they're familiar with, and what they're, certain foods, cleaning products, and stomach acid is hydrochloric acid, ingredients in aspirin. Here's another one. If the student was familiar with ammonia, so like if you've used Windex or any type of that blue cleaning solution, that ammonia. If you've ever had cloth diapers, which you guys probably haven't, they're not, not a big of a fad anymore, but the urea has a very strong, heavy ammonia smell to it because of the nitrogen in it. I loved this student relating it to their work with kidney dialysis and how they have to maintain the pH of the blood of the patient's kidneys. And so there's a lot of places, whether it's in your profession or in your cleaning closet or just in your body, that acids and bases relate to your life. So what's next? Well, we are wrapping up the content. We have just a little bit more to cover, which does include buffers. Buffers are almost like the most perfect way to culminate the quarter, especially for Unit 4, because they They just deal with a lot of different concepts. Buffers get into acids and bases. They get into Le Chatelier's principle and chemical equilibrium and disrupting equilibrium. And then also we'll be looking at calculating pH this week. So you're going to want to make sure that you familiarize yourself with your calculator and how to use those really special functions for scientific notation or logarithms. But exciting news, it is the last week of instruction. This is our last week of class in the typical sense, and next week is technically finals week. So we'll be doing our week just kind of like we normally do: discussion, Edpuzzle videos, Learn Smart assignments, homework, etc. Our week will culminate with the unit test, which opens Thursday, closes Monday. My personal suggestion would always be to do it before Monday. Have Monday be as a, like, if in case something comes up. That way, if something comes up, you still have Monday. Plus, you want to be giving your brain time to be preparing for the final. Finals, we're not having our final on a particular day, just in the same way we haven't with exams. So the final will, theoretically, good Lord willing and the creek don't rise, open Monday and close Wednesday of next week, since finals week is December 7th through the 9th, I think. So for this week, what should you be doing? Wrap up anything that you have left from the last week. The quiz was a practice quiz, so you can do that or you cannot. It was just an optional thing. Read through the next week's checklist, see what we're doing. Make that initial post to our discussion. We are still moving on with those. There is an extra credit survey opportunity, so make sure you look into that, because it's one of those all or nothing. Either 80% of the class completes it and everybody gets extra credit, or less than 80% and nobody gets extra credit. It's really easy, simple, takes just a few minutes just to help me improve my course. Also remember that the watering hole, to post questions there if you have it, but also we'll have a discussion thing for the test, the Unit 4 test, and also the final, and I will be posting resources there as the week progresses, as well as I find them. Just like be thinking about the questions that you have, and then finish strong. We're all getting a little tired, but this is the last bit and you just want to finish strong. You guys have a great week and good luck in this last bit.